Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you doing this problem. I'm gonna solve it live right about now. You'll be ahead of me. 327, count range sum. Given an integer array nums, return the number of range sums that lie in lower upper inclusive. Range sum S of ij is defined as the sum of elements in nums between index I and j inclusive. Okay. I did that hint thing. My friend could never got 80% on her AP bio test, and she's got 100% on the most difficult test of the year. Yeah, that happens. I mean, if you watch my stream, sometimes you see that happens to me, right? Where like on a hard problem, I solve in 5 minutes, and then on a quote unquote dumb double linked list problem, I took like half an hour. So it's just sometimes it is just practice a little bit, because even if you know the answer, like like being able to articulate it, and in programming, that means coding it, precisely means something. But yeah. Okay, so the first thing I usually think about when I come to this uh, is like prefix sum. Does that help? Uh, let's see. So prefix sum allow us hmm, to. I'm also thinking something about like the binary index tree, which we talked about a little bit earlier on the stream. But with negative numbers and without giving the bounds, it's hard to kind of figure out how to do the binary index tree. Um, but hmm, let's see. So I definitely want the prefix sum, I think, maybe. So yeah, that's a little bit trickier with some, but I think what I want to do is basically, I don't have the formulation yet, but I have basically some lookup table. So you can think about like, okay, mm, and uh, because I'm thinking something similar to dynamic programming, where you're like, well, what is the number of count of sub? So there is a, a known problem which is not easy, but it's known-ish, but it's not that known. So, but it's known to me, I guess. Problem where like, well, given an array of numbers, uh, try to find the number of sub-arrays that sums to a given target, right? Uh, and you can do that with dynamic programming in O of n times, but I am trying to, but because for this problem you have a range, so I'm trying to figure out if there's a smart way to leverage some sort of log NE algorithm. Um, but oh, maybe, huh? Can I do something like a prefix sum of the prefix sum? Uh, that would be interesting. Take the prefix sum, you do the lookup table, and then you do a prefix sum on that, maybe. Uh, yeah, so I'm doing this live, and I have not seen this problem before. So if you're wondering why I'm just like thinking, I'm just literally thinking through how I would think about it if I'm on a contest. Um, but basically, okay, let's get the prefix sum number. Let's get the prefix sum up first. Equals to 0 times n plus 1. Someone showed me a clever way to do perfect sum in one line, but then I forgot it. So, oops. Okay. So now we have the prefix sum. What does that mean, right? What are you out time? Well, I mean, obviously it's the wrong answer of it. So this gives us the sum. So the entire sum is, I guess, 2. Actually it fits. So as you insert it, so as we calculate this prefix sum, so the idea behind this is that you would add something. Actually, this is the prefix sum, but let's say you have a running count. Right? So like, I don't know how to express this. I'm still half thinking through it. But let's say you have this number as your, I guess more accurately, you have these numbers. So when you get the -1, you're trying to basically do a query of the count of numbers that are between. There's some inverse thing in here. But basically you're doing a query between numbers that are, and maybe I get the signs wrong, but between like -3 and 1 or something like that, because, and the number of counts on those, and you could solve that with a segment tree actually, now that I think about it, I suppose. Is that right? Is that true? And I'm just making it up. But yeah, because you look at -1 and then and then you look up this index actually. Sorry, the -1 will get you with. I feel like I need the inverse of this. So maybe I need the suffix sum so that you can do the query going for. That is weird. Or not weird, just hard. Maybe I would just use the prefix sum directly. So given that the current sum is 2, well, you know that well, you know that there is a sequence that yeah, I'm thinking and talking. Yeah, I'm just going in loops. It is hard. That is why by the way, that is why when I'm on a contest, I'm able to solve these much quicker. Because also on a contest, to be honest, like sometimes I don't prove something correct, if that makes sense. Like sometimes like, okay, I have an intuition, let's try it, right? But like I feel like when I'm on stream, I'm explaining, I'm like, I'm trying to like make sure I prove it a little bit first before like YOLOing. Okay, so given this prefix, I think So I think there is something to kind of derive from this prefix sum, because given this prefix, what does this mean, right? That means you want to do a query of numbers that are the numbers that you've always seen between between -4 and 0, because -4 plus 2 is equal to -2, and then 0 plus 2 is equal to 2. And this, of course, is the input lower bound, and this is the upper bound, right? Oops. So given that, we just have to hash this in a way, or, excuse me, or more precisely, I mean, yeah, so I mean, I think that's essentially a segment tree. But I'm also just trying to be lazy and not implement a segment tree, because also if this is a segment tree, then I mean, on an interview, I'll just give up. But binary index tree, which I guess is a little bit of foreshadowing as what I did earlier, but with negative numbers, it's a little bit trickier. Um, hmm. Oh, I guess actually, if I used, I guess I could just use a regular tree. Okay, I mean, I'm going to switch languages, even though I love Python, just because I don't want to implement any tree. But I think maybe I can leverage maps in C++. Okay, so let's do that. Do I? And now I'm thinking, do I actually need the prefix sum array? So just to, I guess I don't. I just need the running count, and then put that in a tree. Switching languages sometimes a little tough, but okay, I want to put this. So let's keep a map. Oops, map of. We want a multi-map actually, or multi-set. Yeah. Is it multi-set or multi? And insert count, which is 0, and then after this is roughly something. It's just a thing. Oh, I guess this is actually running count, running sum. Let's just go with sum then, because I'm going to actually use count, and that will make it confusing. And now, I have to get the signs right. That's a little tricky, at least for me, because I sometimes have trouble visualizing this. But this is I have this open up, and in theory, I would also, not in theory, but in general, I actually have pen and paper to kind of help me visualize this. But yeah, how many numbers are between? So we want m dot lower bound. Is that lower bound? Which one is lower bound again? Wait, maybe I'm doing this wrong. Does that work in multi-map? I hope so. but of the current sum. So this is lower. So we want to add lower. And then I guess actually take the negative of the sign. Oops. Okay, so that's the bound that we're looking for. And then we're also looking, this gives us, what kind of, in a multi-set, what kind of iterator does that give us? I should forget. Is it a forward iterator? Sorry, friends. A lot of these things are bidirectional iterator. So I guess my question is whether I can do something like this. That is the lower bound. And then now we want to find the upper bound, which is, I guess, the same logic. Can I do something like that? I don't know if this is quite syntax correct. There is a thing for calculating the distance between two iterators, right? Or am I thinking of someone else? Because in theory, this would be log n for each of these, but I forget the exact syntax though. It's been a while. C++. Just doing a set. So it returns an iterator, and I thought you could just subtract the iterator. Oh, is there a distance function? Am I thinking of another language maybe? Okay, fine. I mean, I'll take it if it works. Also, did I not have a semicolon? No matching function to std. Am I using the wrong? I think there's some like, yeah, okay. And I might actually have these backwards, but let's see. Well, worth a shot. Okay. Because I think you're supposed to put the first and the last, maybe. Maybe that doesn't matter. Maybe they're smart enough to figure it out. But let's at least do that. Maybe I'm also off by 1. So, okay. This shouldn't matter, but I just want to at least be able to defend this a little bit. Time limit exceeded, really. Maybe I am wrong. I didn't really change anything else, right? Whoops, what did I click on? That's fine for now. Let's print it out. I just wanted to, that's why I did it. X and okay. Sum is 0. I can see. Well, no elements doesn't really need it. Okay. So the current sum is 0, -2. So print out the count. This should actually be 1 because it should include itself. Well, that's okay. Let's take a look at the upper bound and lower bound that I'm looking for. Also, I think my upper bound may be off by 1. I was thinking that a little bit, even when I was doing it. So I always okay. I forgot to use more format parameters. Okay, so for -2, it searches for 4 and 0. Is that right? Well, it should find a 0. Is the upper bound number wrong? Why is this returning 0 then? I mean, this should return the end of the multi-set. Unless there's some like weird stuff with the end of it. Maybe I need to do. That should still maybe return m.n, but is the distance not right for m.n? Thanks, Dow too. You are not wrong. I'm just old school in my ways. Why doesn't this? All right, let me try it. Actually, I don't. What does that? What does cout do if you? Actually, don't know cout that well. If you just return like something like that, does that work? I actually don't know how the magic. I guess it just calls the thingy. Yeah, well, okay, then it does nothing for me. No, but M should. Why is that time limit exceeded? Maybe this distance function is a little bit weirder than I know. Okay, so distance actually is not all of one anyway. It just uses the increase operator repeatedly, which for me is not super helpful in terms of, okay, fine. Also, I get the direction wrong, I think. So this is a case where I know the algorithm, but then implementation is always trickier. Let me think about what I want to do with this. The idea is okay, but yeah, wait. I thought you could do something like this in multi-set, but I don't remember. Do I need a? Whatchamacallit? A segment tree? I haven't done a segment tree in literally decades. And it's funny because I think Mbrex was talking about it yesterday. But I think that would actually, I mean, for sure, I think that would solve it. But is there a non-segment tree way of doing it? Okay. I need to be slightly smaller than that. Okay, so I gain nothing by having it in whatchamacallit, but in C++. I'm just thinking about also the other ways of doing it. Maybe maybe I could do some sort of binary search. I mean, essentially it's the same idea, but then with the binary search, you have to keep the array in a good place or sort it, which is essentially why I'm doing it this way with the binary tree-ish, because I mean that's literally why I'm doing it like this. But let's see. Yeah, I got it off by one. Oops. Okay. I always forget when to use upper and when to use lower. Is that fast enough? I have some, because this is actually, oh, well, okay. Maybe I'll worry about it after I get it right. Hmm. What? Oh, yeah, I mean, I knew that, but okay, so 0, this insert 0, but the distance, hmm. Hmm. Am I off by 1 again? But the bounds are 0, 0, so sum is 0, so why should it not return? Oh, I guess these are the same numbers, that's why. What are my inputs? I need someone like just +1 or something. Maybe I think I had that, but I had to. I think I confused upper bound, lower bound because I'm taking the negative of it. But then now I have too much, so no. Maybe now I don't need this. Whoop. Hmm. Hmm. Well, I have no idea. Why is... Oh, that's why I have the upper bound, I suppose. Let's just try upper bound. Yeah, the upper bound here by accident before, because the negative numbers I should have swapped them, but okay. So that's still wrong, but maybe hopefully a little bit more right. But why am I getting hmm. Why am I getting 4 here? x is only returned 1, 2, 3. Oh, because I don't. Search from 04 to 0, which is fine. 0 to 4, so it finds 1, that's good. It was even in the description, right? -1 to -5 to -1, which is true, I guess, because there's one version of -2, but I don't think that should. This returns 3, so that the sign's wrong. I guess I was signs are wrong. That's why I was struggling a little bit. Because what you want is I guess that was one of the things that I was a little bit worried about in the beginning, which was the signs. Okay, let's print it out. Let's submit that. Okay, I'm happy with that, maybe. Oh no, oh, overflow, okay, fine. They don't tell you, I blame it on them. Okay. What's this? Okay. Count should still be okay. Everything else is maybe okay. I'm gonna put it in. Hey, how you doing, Yasin Dante? Hope you're having a good night. Sorry, I think I'm really close, hopefully. So we finish this problem. Okay. I thought about this before, that's why. But I was like, oh, we probably don't need it. Okay, that's good. Yeah, I mean, okay. I mean, this was a very hard problem for me anyway. I think I knew how to do it. Or at least I have the idea behind it. But, and to be honest, I think mine is a little bit, how do you say this? This is almost n square, even though it's not the naive n square, but because the distance actually walks the tree instead of getting some bounds, which using like a segment tree or something like that, you could get this in O of log n time instead of maybe O of n. But yeah, using a segment tree or some sort of binary search tree with and you would have to kind of implement the binary search tree by yourself. I would say, yeah, you could do this in n log n time. I don't know if I have that much. I don't know how much tips and this is of n. In insert is always going to be log n. I don't know how many tips I have, to be honest, because you because if you watch this, then you gonna you see me struggling. I actually got this. I want to say that I did get this like relatively quickly in algorithms, but not the coding. I think one thing kind of like for me to add to my to-do list is to just like really study segment tree. If I had segment tree, like I know how to kind of do it, but I haven't implemented in years, and it's not a trivial thing to implement from memory, and it's not from memory when you don't have it in memory. But So I think if I had that, then this is like essentially there's like you use a segment tree, then you like do an increment on the sum, and then there's like a get something, and then that would give you, and then essentially the code looks very similar, except for it's backed by a segment tree that if you use it as a abstract data type, that's how it would work. But I think, yeah, my evolution of how to kind of, yeah, if you get this on an interview, you're probably not having a good day anyway. So I don't know. I mean, I think I say that a bit, but I think like unless you're really strong on like a lot of other algorithms, then I'm not a fan of segment tree or binary search trees and those things. Or sorry, binary index tree. Binary search tree is fair game, I suppose. At least in terms of talking about it, I think no one expects you to implement a balanced binary search tree in an interview, but you probably expect to at least be able to talk about it articulately. Yeah, and I think for me, the biggest thing was just going through the prefix sum, just because prefix sum allows you to answer queries between in all of one time, the sum between two indices. And from that, it reminded me of the classic dynamic programming problem of how many subsequents are summed to a given target, except for in this case, the target is a range from lower to upper, which for me suggests like, I mean, whenever you see these like upper lower things, maybe not all the time, but because sometimes if the delta is small enough, you could do something linear. But for me, if there's some sort of ordering that we can take advantage of, then it suggests some sort of trees, and you can kind of reason that about because like, and I kind of use the analogy of prefix sum of a prefix sum in the way that you if you think about I don't know how to explain this articulately, but yeah, if you look at the prefix sum array, which I have somewhere actually, yeah, like I mean, I think I have essentially. I mean, I've actually explained this part a little bit. Maybe my signs were wrong, which also cost me some time. But you have this prefix sum in order for this minus. I guess that's where I got these signs wrong. But yeah, I got some signs wrong. But essentially, you want, given the number 2, you want to subtract. That's why you want to subtract a prefix such that the remainder, which is the sum between the index and your current index, is between the lower and upper. And because you know the lower and upper, you could just do the math backwards. I mean, I clearly did not because I got the signs wrong, but that would be my idea and how to kind of think about it. Yeah, I hope that makes sense. There are a lot of, because I think that's, I mean, for me, and you kind of see my logical progression, but it's clearly not easy. And each of maybe the first couple of steps are kind of things that I would maybe expect someone to get. Prefix sum, for whatever reason, it has become very popular, and I don't know, it's just like a very simple quote unquote dynamic programming slash query lookup slash pre-calculation type thing. So it comes up from time to time. So that definitely something that I would study. Even the dynamic programming thing where like number of subsequence subsequence that or subarrays that sums to a target. Even that is a little bit on the harder side. At least on competitive programming, I feel like for whatever reason they expect everyone to know it by now. But I think it's a little bit non-trivial. I mean, you just have to learn it for competitive programming. For interviews, I don't know if I would. And then from that, you have to do another prefix sum, which you can which given that it's if it is static, then you could have done a prefix sum on that and then do a binary search to calculate the number between two numbers. Like basically you have like an array and then you just get the bounds, and that's log n essentially also like kind of this really, but just given in an array, right? But because we have an insertion, that makes the problem dynamic, and it forces you to add numbers between, or well, one number. Uh, well, it forces you to increment a number from, in this case, my variable of sum all the way to infinity, in the sense that like you increment one by all those things, which is something that's taken, uh, um, which is a property that segment tree type problem solves for you, which is how I make that leap. But yeah, so there is a lot of a lot of steps to solve this problem, and and like I said, even if you got all that on the algorithm side, the implementation isn't trivial either. Even though I did it in a cheesy way, that's not technically n log n, and that's why the code is but it's just it's way faster than a naive n square, but it is not strictly O of n log n, but it is a faster n square per se as a result. But but yeah, I think that's all I have about this problem. I It is a hard problem, so definitely I would wait until review. Wait until you're good at everything else before solving this problem. I think, I mean not everything else, but like other similar leveled problem. Because I think if you're studying for an interview, then there's a lot. Like I would rather be like get my foundation on something as trivial as binary search, make that foundation stronger, rather than like wondering what would happen if this shows up on an interview. If that makes sense. Uh, cool. Uh, you can also do k-order statistics with these prefix and subtracting prefix. Yeah, I mean, I think that's essentially what I'm trying to do, but because this is dynamic, so yeah, like you have to do it dynamically as you insert more and more numbers. So I think that's the tricky part.